Alright, so quadratic simultaneous equations. It definitely is a difficult topic, but you'll see with a bit of consistent working, it's actually not that bad. Yeah? So, before we do quadratic simultaneous equations, let's remind ourselves how we do linear simultaneous equations. Now, obviously, when it comes to linear simultaneous equations, they can ask that in the context of, going to the shops. If I buy 2 apples and 3 bananas and it costs me 5 quid, and I buy 10 apples and 2 bananas and it costs me 16 quid, how much is an apple and a banana, that kind of stuff, yeah? But I'm just going to do the algebra side of this stuff. So from previous years, we will have learned how to solve linear equations simultaneously, either by elimination or by substitution. Now, in terms of linear simultaneous equations, I would say elimination is usually the easiest, yeah? So for example, solve 3x plus 5y equals 3, 4x minus 2y equals 13. You scale it so that either the x's are the same or the y's are the same. And then you can either subtract or add to cancel them out. I'm just going to do it with the x's. I think it's easier if we do it with the x's. So we have a 3x and we have a 4x. So we look for the lowest common multiple, and then we can equate the x's. So the lowest common multiple of 3 and 4 is 12, right? So to this equation, we would have to times it by 4. And to this equation, we would have to times it by 3. So the first equation, if we times it by 4, and the second equation, if we times that by 3. So when they're exactly the same, yeah, good. When they're exactly the same, you minus them. If they are the same, but one is a plus and one is a minus, then you add them. Okay, so take them away. 12x take away 12x goes. Now make sure you read it out loud in your head. 20y take away minus 6y. The double negative becomes plus. So 20y plus 6y is 26y equals 12 minus 39. 12 minus 39, the way I do is I just do 39 minus 12, and then I just make it negative. 39 minus 12 is 27, but because we were doing 12 minus 39, it's actually negative, yeah? Then to get y, we divide. So we're going to divide both sides by 26. So that cancels, so our y value is minus 27 over 26. Then what we do is we substitute that y value to any of the equations to find out what x is. I think it's easier to put into the first equation. Yeah, so we'd have 3x plus 5 lots of y equals 3. And then we want to do 5 times this number. I think it's fine for us to put this in the calculator. Fractions knowledge. So we got minus 135 over 26 equals 3. Then we'll add that to the other side. I'm going to go over here. So we got 3x equals 3 plus that number. So in the calculator, I'm going to do 3 plus the 135 over 26. So we've got 213 over 26, and then we divide both numbers by 3. Now, in the exam, they may put x equals, and then you just put in your number, and then y equals, and then put in your number. But really, these two equations are lines, and what you're doing is you're working out where the two lines intersect each other. So the x and the y are actually coordinates. So I'd prefer if you guys told me this. Tell me the coordinate solution. The y coordinate was 27 over 26. That's the best solution. But when you're doing your GCSE paper, just keep an eye on the answer box and see how they want you to write the answer. Hey guys, I hope you enjoyed my video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button. Comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. So let's try again. Solve x squared plus y squared is 17 and x plus 2y is 2. Now, in terms of your subject equation, always rearrange or use the equation where there's no squares in it. Yeah. So for this second equation, x, the 2y is just going to go over, right, to become minus 2y. So you're going to get x equals 2 minus 2y. I like to put a box around this. It reminds me that this is the subject equation. Then you take that and sub that value into the other equation. So we rearranged for x. We're now going to substitute that in for x there. Remember, when we substitute, use a bracket. So we're squaring x. X is 2 minus 2y. And we're squaring that. Plus y squared equals 17. Now when we square this, we obviously have to write the brackets out twice. So 2 minus 2y, 2 minus 2y, plus y squared is 17. Expand. Yeah. Simplify everything. We got 4y squared plus y squared is 5y squared. Then we have minus 8y. Then we have the plus 4 is 17. Then we can move the 17 over. Yeah, we'll do 4 minus 17 equals 0. Even if it looks horrible, don't forget my tricks that I taught you guys. 5y squared means it needs to be 5y and y. 13 is a prime number, so you can only have 1 and 13. Now think about this. 13 cannot go here because you'd be doing 5y times 13, which is a massive number. The middle number is 8. So I don't think we want the 13 there. I think we want the 13 here and the 1 here. 13 times 1 gives you your 13. Then we check. 5y times 1 is 5y. Then 13 times y is 13y. How does 13y and 5y ever make minus 8y? Is if you have minus 13y plus 5y. So either minus 13y plus 5y. Yeah, so it's really easy to factorize. Well, it wasn't that easy, but it was easy enough. Yeah. Now remember what we say. We say either 5y minus 13 equals 0, 5y minus 13 equals 0, or y plus 1 equals 0. Move the 13 over and then divide by 5. You'd get y equals 13 divided by 5. Then here move the 1 over, y equals minus 1. So just as advice for you guys, if it's a non-calculator paper, always try your luck with factorizing. Yeah? Although completing the square is an awesome technique to do all this as well. Okay, then remember, once we have the y values, we sub it in to get our x values. So x equals, now it'll be 2 minus 2 times 13 over 5. So if it's a non-calculator paper, how are we going to do this nice and quick? We're going to have 2 minus. Now when you do 2 times a fraction, you always times the numerator. So it'll be 26 over 5. Then you have to combine this. When you do 2 minus 26 over 5, you write 2 as 2 over 1. Then you have to times top and bottom by 5. So it's 10 over 5 minus 26 over 5. 10 minus 26 is minus 16 over 5. So the coordinate for this one is minus 16 over 5, 13 over 5. And let's do the other one. We have x equals 2 minus 2, and the y value here is minus 1. This one's an easier one to do. Minus 2 times minus 1 is plus 2, so x equals 4. So the solution here is x is 4, y is minus 1. And they are your two solutions. Next thing, which is way easier than what we've done, is quadratic inequalities. The main thing with quadratic inequalities is, do you guys know how to factorize? And I'm hoping by now the answer is yes, we know how to factorize. With quadratic inequalities, we always have to factorize. There's no other way. So, solve x squared plus 2x minus 15 is less than 0. So, we factorize first. 5 and 3, I need a plus 5 and a minus 3 to make a plus 2x, right? Now, we have to make sure we get the correct inequality as a solution. So the way we do that is we sketch the quadratic in a very basic way. Now, what I mean by that is usually when it equals 0, we would say x plus 5 equals 0 and x minus 3 equals 0. If x plus 5 equals 0, you would get x equals minus 5. And if x minus 3 equals 0, you would get x equals 3. But they are not the solutions because we have an inequality. What we do is we sketch the quadratic. Remember, when a quadratic equals 0 is where it crosses the x-axis. So you would have minus 5 and you would have 3. So the quadratic looks at, in a very basic way, something like this. Yeah? Now, what the question is saying is, when is this quadratic less than 0? Less than 0 means below the x-axis. That's when the graph is negative. Now you can see the graph is negative here. Yeah? That's where the graph is below the x-axis when it is negative. All you need to do is write down what the x values are, which define that section. So what I do is I draw arrows up. So the quadratic on the x-axis are these x values. Yeah? Those are the x values which give you the negative side of the quadratic. So all you need to do is write down what those x values are. On a number line, those x values are anything between minus 5 and 3. Yes, these x values. Think of the x-axis as a number line. So your answer is x is anything between minus 5 and 3. So this inequality here, in English, is just between. It can never be the other way around. Yeah. So when you see that inequality, if I ever say between, I'm always saying that inequality. So you see how it works in terms of part B. The first thing we need to do is move the 6 over. So it's 3x squared minus 7x. Then when we move the 6 over, it'll be minus 6 is bigger than or equal to 0. Now when we factorize, we're going to have 3x and x bigger than or equal to 0. 3 and 2. Now let's see what happens. 3x times 3 is 9x. 2 times x is 2x, which can make minus 7 if we have minus 9 plus 2. So we need that plus 2x and we need that minus 9x. Now we do the same thing. If 3x plus 2 equals 0, we move the 2 over, it'll become minus 2. X will be minus 2 over 3. And here, if x minus 3 equals 0, x would be 3. Then we draw our picture. We have minus 2/3 and we have 3. Here's our graph. Now this time, we want to know when is it bigger than or equal to 0. Bigger than, meaning when is it above the x-axis? Well, the quadratic is above the x-axis here and here. So from there, we draw lines down to the x-axis, which is the number line. So we draw lines down. These are the numbers on the number line. The x-axis represents the number line. Here, here, here. So it's these x values and these x values. You just have to be able to define those. It has to be equal to. Yeah? Here it says bigger than or equal to, so my solutions have to be equal to as well. That's all.